Look at the news, the culture wars, the economy. The world feels incredibly fragile right now, like it's vibrating at a frequency that's too high. Usually, we reach for sociology or political science to explain this anxiety. But today, we are going to diagnose our societal stability using hard physics. This framework relies on the concept of isomorphism. It is the hypothesis that the mathematical laws governing the universe, the rules that dictate how energy cools into matter, continue to operate when human beings form a society. They simply change form. Think of nature as a highly efficient coder. If an algorithm works to bind quarks into a proton, and then works again to bind atoms into a molecule, nature upgrades that software to bind people into a community. In this view, human sociology is condensed matter physics operating at a higher level of complexity. To understand how this works, we start at the subatomic level. In the standard model of society, individual humans function as the foundational particles. In physics, forces like magnetism are the result of particles constantly throwing and catching tiny packets of information called bosons. In the social world, the fundamental boson is choice. Every time you vote, buy a specific brand, or sign a contract, you are throwing a packet of force into the system. Visualize two skaters on perfectly frozen ice. If they throw a heavy medicine ball back and forth, the physical impact of throwing and catching creates a rhythm that locks them into a shared system. The force holding them together is generated by the act of exchanging the ball. But if you throw the ball and the institution fails to catch it, if your vote is ignored or your speech is silenced, the bond fails to form. You simply drift. Cohesion is a physical requirement of reciprocity. This model also explains the nature of power. Just as particles gain mass by interacting with the Higgs field, leaders acquire political mass by interacting with the field of public belief. The crowd clumping around a figure creates the weight we perceive as influence. This mass generates the gravitational pull that allows a leader to move others. Because that gravity is a product of the external field rather than an internal quality, a sudden shift in public belief can leave a formerly heavy titan completely weightless. When we scale this up to billions of particles, the question shifts from individual agency to collective stability. Physicists use the Ising Model to predict the behavior of magnets. It shows that stability is a war between two variables, the coupling constant, or the glue holding neighbors together, and temperature, the random energy shaking them apart. Culture is our coupling constant, the shared traditions that make us align with neighbors. Information is our societal temperature. The constant friction of digital noise introduces thermal energy, keeping particles vibrating violently. We are currently living in a high-heat civilization, pumping exponential amounts of information into a system, while the cultural glue that maintains alignment is actively dissolving. In thermodynamics, there is a specific threshold called the Curie Point. This is where the heat finally overwhelms the binding glue. A magnet does not slowly fade. It holds its structure until it hits this limit, at which point it suffers an instantaneous phase transition. The order collapses into noise in a single moment. History shows us these transitions. The Soviet Union appeared immovable for decades, but the internal heat of economic failure and leaked information reached a critical peak. When the glue finally failed, the massive structural order vanished almost overnight. If the temperature of our information environment continues to climb while our cultural alignment weakens, we track toward a threshold where the math dictates a total loss of societal coherence. Since we cannot realistically turn off the digital furnace, survival becomes a question of material science. We must choose what kind of structure we intend to be. Rigid societies act like glass. They use totalitarian control to resist all change. While they feel strong, they cannot absorb energy. When the stress exceeds their stiffness, they don't bend, they shatter. Resilient societies act like rubber. They stretch to survive a crisis and then bounce back to their original shape. This allows for survival, but it resets the system to the past, resulting in stagnation. A third strategy is antifragility. These systems harvest the energy from disorder to reinforce their own architecture. In metallurgy, this is known as work hardening. By subjecting a metal to physical stress, you create a traffic jam of dislocations, tangling the internal structure until it becomes exponentially stronger. To survive a high-temperature century, a civilization must stop shielding itself from the heat and start using the stress to work harden its social lattice. But physics is ruthlessly honest. Work hardening is path-dependent, meaning the strength cannot be acquired without traversing the actual load. We risk creating a false hardening when we use external scaffolding, like lowered standards or engineered outcomes, to prop up a weak system. This produces the appearance of strength without the internal structural change. This is the danger of corporate bailouts. An entity is labeled too big to fail and propped up by the state. It looks like hardened steel to the market, but it retains the weak microstructure of soft iron. Structural integrity does not care about political optics. If we want to survive the heat of the future, we must tear down the scaffolding and embrace the genuine work required to build a society that is truly unbreakable.